We're going well so far. There we go. Okay, that looks better. Let's try this. Okay, cool. Okay, so hi everyone, I'm Mike. Thank you for having me today, and thank you, Craig, for the invite. So I'm going to talk about progressive web apps today and offline development, and not so many cats. So quick introduction. As I said, my name's Mike. I'm a full stack developer. I write LAMP and Node, and I run Maiden Academy. We are a training organisation based in Bath. We provide bespoke developer workshops and training, so if anyone's interested in that, please come and talk to me afterwards. We also run a boot camp for aspiring developers. But basically my role there is to learn about new technologies and then teach them to other people, which is pretty cool, and it means I get to come and do stuff like this. So one of the technologies we've been playing with quite a bit over the last year or so is progressive web apps, and that's what I'm going to talk to you about. So the first thing that I asked myself when I started looking at progressive web apps, this PWA thing, was, what is a progressive web app? So you Google that term, and the Wikipedia quote says that a progressive web app is an experience that combines the best of the web and the best of the apps, which sounds great, but actually doesn't tell me anything about what it actually means for me as a developer. So a progressive web app, or the term progressive web app, first came about from a guy called Alex Russell, who works for Google, in an article that he wrote on his own blog in 2015. And he wrote an article about the problems that there are currently, or were, with native applications and mobile web. Why do you have to maintain both? They're almost exactly the same. Okay, you get a couple extra features with native mobile apps, but for all intents and purposes, you're building the same thing like twice, just in two different languages for use on pretty much the same device. So he came up with this idea that actually, let's just bin the native apps and let's just make your web app, your already mobile optimized application, appear like it's a native application. It would be able to work offline, doesn't have to. It would be operating system agnostic, so work on Windows Mobile, work on Android, iOS, and maybe even OS X. This article actually came out not long after Microsoft had kind of tried to do something similar. In the Windows Mobile, they kind of tried to create these apps that you download through the browser, and it never really took off. They didn't really do a lot of marketing, didn't really tell a lot of people about the fact that they were doing this, and they didn't really go about it the right way. So it didn't really ever take off. But Alex Russell came along with these ideas, working for Google, and kind of made it happen, I guess. So it's basically your mobile web application already. You've already got the one that runs through the browser, but with a little bit more JavaScript in it. There's actually not a whole lot that you have to do in order to turn your existing mobile optimized web application into a PWA. So that's what we're going to have a look at today, how you might do that, the technologies behind it, and what it will achieve. Currently, if you want a mobile app on your phone, you either go to a website, you get a little prompt that says like, oh, we have a mobile app, come and download it from the App Store. And you click the little prompt and you go and you download the app, and it takes like 5-6 seconds if you're on Wi-Fi, and then you open the app and then you have to find the page you're on already, and it's a bit of a pain. Or you knew that you wanted the app anyway and you never went to the website, you just went straight to the Play Store or whatever it is, and you downloaded the app, and it takes a lot longer to get to it. You have to actually install this thing in order to start using it. And usually it requires quite a bulky download. So the idea behind a progressive web app is that rather than installing an application in order to use it, why don't we just start using an application and then it will just install itself? Why do we have to go to this app store, which is nothing to do with your business, nothing to do with your website, in order to download this application for your users to start using? So So the idea of a PWA is, well, we don't need an app store anymore. We've already got our mobile optimized version of our web application. Our users can just go there and start using it. And then in the background, it can just download itself onto their phone. It can be nice and small because it's written in JavaScript. And then they can just instantly start using it. They don't have to go via an app store. They don't have to have any big, bulky download. Now, in order to make this work at the moment, in order to trigger this automatic download in the background, you have to, as a user, be considered a regular user of the application. Now, Google defines a regular user as somebody who visits the site at least twice with at least 5 minutes in between each visit. Which, okay, I don't know how regular that makes me if I've been there twice, but I'll go with it. So it kind of looks like this. Now, this is quite quick, so I'm going to let you watch this a few times. But you Google the application, you load it in your web browser, you get a pop-up that says, oh, add it to your home screen. You click the pop-up, and it adds it to your home screen like an application, like a mobile app. When you click it, it opens full screen, and you get what looks like a native app. I'll let you watch that again. Yeah, so add to home screen, adds it to your home screen as if you'd installed an app. You can click it, and there it goes in full screen. Okay. Now, there are a few different ways of doing this, and we're going to talk about the different things you can do. The main question I get at this point is, well, it doesn't look like an app because it's still got the Chrome logo on it. I actually couldn't find a GIF that was pre-made that had a custom logo on it, and I didn't have time to make my own GIF. But you can customize that logo. If you don't customize it, you get the Chrome logo or Firefox or whatever browser you're using. But you can set your own logo for that. So it does actually look like a native application. OK, let's talk about why you might want to do this. So we can have a look at some statistics. So Tinder built their own PWA. I think it was probably about a year ago now, actually. And they found that they cut their average load times versus native from 11.91 seconds to 4.69 seconds, which is a pretty good speed increase. This mostly came from the fact that the PWA, which is written in JavaScript, is 90% smaller than the actual native Android application. It's pretty good in my book. OK, so Uber also did it. Now, Uber wanted to make sure that their application or their PWA was really, really small in size, so that even if you're on a 2G network lost in the middle of nowhere and you have no idea how to get home, you can still use it. So Uber's PWA takes less than 3 seconds to load on a 2G network, which is pretty good. Saved me getting home a few times. OK, Trivago. Trivago found that by implementing a PWA, that they actually had an increased amount of user engagement. Now, this wasn't actually to do with the load time, as the previous two examples. This was just because nobody could be bothered to download the Trivago app, because you only go on holiday once, maybe twice a year, if you're luckier than me, 3 times a year. So they didn't want an app sitting on their phone that they were only going to use 2 or 3 times a year. Whereas now, you can just go to the Trivago website, and if you've been there before, it'll silently download in the background, it'll work offline, it's quick, it's easy to use, and therefore, their user engagements went up. Resulted in 97% increase in hotel offer clicks, which is a pretty big increase. That's versus the native application. And it also resulted in 67% of users continuing to browse whilst offline, because they implemented offline support. OK, last one. So Pinterest, came out not all that long ago now. And they saw that their user engagements went up by 60%. Again, this was because not as many people were installing the application through the App Store. But when it downloads quietly in the background, people don't mind. That little pop-up, you just click yes, it's nice and easy. It's not a big bulky download, doesn't take up a lot of space on your device. Why not? So 44% increase in user-generated ad revenue, just generally more people using it, therefore more money. And the time spent on the site increased by about 40%. This was mostly due to the offline support they implemented, so you could continue to browse profiles and things like that when you weren't online, provided you downloaded the data. We'll talk about that in a bit. So that's some statistics as to why we should use a PWA, what it's going to benefit you guys with. So now we're going to talk about the interesting stuff, how do we make your application into a PWA. So you actually need 3 things, but I had to add 4 because it bugged me that my slide wasn't symmetrical. But we are going to talk about the web API anyway. So you need HTTPS. Hopefully everybody in here is already running on HTTPS. Come and talk to me after if you're not. You need a service worker, which is what we're going to spend some time looking at, which is a bit like a client-side proxy, sort of. Allows you to control your HTTP requests. And you need a web app manifest, which we're going to have a look at too. And then you probably want to make use of the web API. So we'll start with the web app manifest, because it's very simple. It's just a JSON file that you link to from the head of your HTML using this. In the JSON, it allows you to specify what your user's device will treat the PWA like. Okay, how to. It's basically the settings, the configuration. Okay, so things like the background color of the splash screen, the name of the app that will show on their home screen, the URL that you want it to load to when they open it, because it doesn't have to be your home page. Yeah, I'm not going to read them all out. You get it. It's pretty simple. You specify some different icons as well. It's an array, so you can put a few different sizes in there, so that it will work on an iPad and an iPhone and all the different devices that you want to support. And you can even specify the orientation that it'll open in. So if you want it portrait or landscape. Now the important one is the display standalone one. So you basically have 2 options. I mean, there's more than that on some devices, but you basically have 2 options. You have standalone, where it will run in whatever your default browser is, so Chrome on the device, but it won't actually run in the standard version of Chrome. It will run in a separate, or what will appear to be a separate application. So when you open that list of all the applications that are currently running, it will be a separate one in the list, and you can switch between it and your actual Chrome. You can just get it to open in Chrome, but you might as well just have a bookmark if you're going to do that. Okay, so that's a web app manifest. Then we need a service worker. So a service worker, as I said earlier, is a client-side proxy, or it's a bit like a client-side proxy. It runs in a separate execution thread, so it doesn't interfere with your normal JavaScript. Doesn't have any DOM access, which is actually really annoying when you start doing this. But the more you play with it, the more you realize that you probably don't need it that much. Although it is possible now with the post message API, which is a web API. I mentioned you might need those. You can communicate between your service worker and your standard JavaScript thread using it. And it basically can interact with all of your network traffic, all of your HTTP requests. It's usually used for cache management, but it can do a lot more than that, so we're going to explore some of the other things that it can do. Although we will look at cache management too. So let's have a look at some code. In order to register a service worker in your application, you need a service worker file, which is a separate file, and then you just need to register it from your standard application. So we can just chuck this code into the script tag in the head of your current application after creating your service worker file. And this will register the service worker for you. Okay? So basically, we just start by checking, well, can we use the service worker in the current the current device? If so, register the service worker based on this service worker file. Give it a scope, which tells it, it gives the service worker permissions, basically, so what network requests can it interact with and what can't it. So if you only want it to be able to see your domain / app or mobile app or something because you've got a separate directory for that, then you can scope it. It's all promise based, so it will return a promise for which you can hook into to say, yeah, it worked or no, it failed. It'll only fail if you've got an invalid service worker. And then obviously, so I'm just console.logging stuff out. OK. You can put this in an external file and link to this code. But actually, because it never really needs to get any longer than this, and you'd probably strip out the console.logs anyway, the advice is to just chuck it straight into your head. And that's it. We're done. Questions? No, I'm joking, obviously. It's probably not. You probably actually want to put something in the service worker. Now, technically, you actually don't have to. According to the rules that Google have set up, if you have a registered service worker, it doesn't have to do anything, but if you have a registered service worker, you have a registered web app manifest file, and you're running on HTTPS, those three things, then when your user visits more than twice within 5-minute gap, they're a regular user, it will trigger the install to home screen pop-up. So you could actually get it to look like a PWA without doing basically any work if you want to, but probably not. So let's have a look at some of the things that we can do inside our service worker. I mentioned earlier that we use it a lot for cache management. So this is a very simple example. We're going to use the cache API. So this is inside our service worker file, that sw.js file that we saw earlier. We use self to refer to the service worker itself. Now, it's event and promise based. So we can hook into the install event, which gets triggered once the service worker is installed. And then we can make it do some things. So this one just opens a new cache called cache demo and adds my.css file into the cache. Doesn't actually do anything else, doesn't ever retrieve anything from the cache, it just adds that, because why wouldn't you? But it's very simple. So we can make it do a little bit more than that. We can also hook into fetch requests. So AJAX requests, XML, HTTP, works with that, works with the new fetch API. Basically any HTTP request that you do will trigger the fetch event inside your service worker. So here I'm hooking into my fetch request. I'm then checking my cache as to does the request, does the file that I'm looking for match anything that I've already got in my cache using this cache.matches with the event request. If it does, then we can just return the file from my cache. We don't actually have to go across the network to go and get it. We just get it straight out of the cache. And if it doesn't, then we'll actually execute a fetch request. And we just pass the request straight into the fetch function, and it will go and get it. Now, you probably want to do a little bit more than this. This code is not complete. So when I publish my slides, don't just copy and paste my code. Probably doesn't work. Not completely, anyway. But you get the idea. Very simple. So we have the ability to control our HTTP requests, which we've done some cache management with. But we can do a lot more with it. So how about controlling how often we actually go to the server to get back some data? What if we know that our data only updates once every 5 minutes? There's no point in the user constantly refreshing because they're waiting for the new data and just hitting your server, wasting your traffic on AWS or whatever it is, when you know that the data hasn't changed. So we can implement here. This is a very simple example of what we were looking at before. But this time we're just setting a date, checking whether the last request went out more than 5 minutes ago. If it did, then it goes and gets some new data. If it doesn't, or if it didn't, then it will just return the data that was in the cache. Earlier you saw that I put a file in my cache. You can put other stuff in it. You could put some JSON in it. And we're going to talk more about what you might do with that, but you can put anything in it. It's text-based anyway. So let's have a look at what's actually happening. So the user makes an HTTP request to start with to load your page. Upon that load, you grab the data and you store it in your cache. Okay, so your JSON or whatever it is. The user then makes some kind of interaction with the page. They refresh it or they go to a different page that requires the same kind of data. Your service worker kicks in because it picks up the fetch and makes some decision as to how to respond. The response comes back from the service worker, whether that's from the cache or actually having gone over the network to your server. And then your client updates the DOM with your response data. As far as your client's concerned, nothing's changed. You don't have to update anything there. It's just a standard request. So we're going to have a look at this bit in bold, the stores data. How do we actually do that? We've looked at the cache API, but if we're storing JSON, we can do a lot better than that. So there are a few ways that we can store data on the client side. We've already looked at the service worker cache. Generally, this is used for caching static files. Obviously, it's a cache. But it does work with data. You can put JSON in it. Anything text-based you can put in it. But all you can do is put stuff in it and get it back out. It doesn't really have a lot of, it can't do anything else. So let's have a look at other options for storing data. We've got local storage, the HTML5 API. It's quite similar to the service worker cache. You just put data in it and get stuff back out. It's very simple. But it works synchronously, and service workers are asynchronous. Therefore, it doesn't work with your service worker. You can't use it. So sorry for anybody who is already using local storage to store data on the client side. You can't do that with your service worker. However, we can use Indexdb. So Indexdb is similar to the local storage, except that it is asynchronous. And it's more like a database that's stored in your browser on the client side. Because it works asynchronously, it can be used with the service worker. And actually, it can be used for, it's a lot more powerful than the local storage or the cache, because you can actually use it for searching data. So we're going to have a look at that. It's very good for storing, now I'm going to say large amounts of data, but that depends on your definition of large. I know some people here probably work for very big enterprise companies, and I work for quite a small startup. So large is relative. But it's better for storing much larger amounts of data than you can put in local storage or in your cache, for example. So Indexdb, client-side database, used for storing large amounts of data, usually JSON, but whatever. It uses indexes, so therefore it is high performance for searches. So just like a database, we can actually index our data and then pull stuff out of it very quickly. It's asynchronous and promise-based, and it's actually a permanent data storage. I did a bit of playing with this one. It was a bit of fun, actually. I wanted to see what their definition of permanent was. So you can delete the data that you put in there via your developer tools, of course. So it's not like you can't actually delete the data. You can delete the data through your JavaScript, through the API. It's got remove functionality. But the data doesn't actually expire at all. So unlike some client-side storages, the data won't actually ever disappear until you remove Chrome or it's removed in one of those other two methods. The data is completely persistent, as far as I can tell. I thought maybe it would have like a year shelf life or something, but no, it just stays there forever. It's not even storage-based, session-based. So Indexdb gets about 1K reads per second, which is not bad for front end. The writes depend on the data that you're storing, so there's no stats I can't give you on that one. And generally for small to medium-ish, for amounts of data that you're reading, it is generally quicker. So how do we use Indexdb? Well, it's actually not very hard. We can connect to the database by doing db transaction and give it the name of the database that you want to connect to, which is effectively just creates one if it doesn't exist already. Give it the permissions, read write in our case. And then you specify the object store, which is like your table. Okay. So because I'm really smart, I called my table and my database the same thing. Probably don't do that. Once we've got our database connection, we can put stuff in it with add, which takes just two arguments. The second one is optional. This is me adding in some JSON, my name, set to the key of 1. Oh, my slide doesn't fit. Oh well. If you omit that, it will just auto-increment the key for you. Then we can get data back out by calling the connection.get, specify the key, and it will pull out the data that we've just stored. We can then change the data with put, specifying the key, and it'll update. Very simple. So let's go back to what we were looking at earlier, which is the fetch request, but only after 5 minutes has passed. This time, once we've made the fetch request, we're then going to, I hadn't put all of the code in, but we're going to connect to our Indexdb database. We're going to add the response data into it using the ID. And then we're going to return the response. As far as the client's concerned, nothing has changed. It doesn't know that we've stored anything in Indexdb. It doesn't need to know that. But it means that the next time that we come and do a request, as long as 5 minutes hasn't passed, it can just go into our database connection, grab the data based on the ID of the request, and it doesn't have to go over the network, but it can pull it out very quickly. Okay, so offline development. Well, we've kind of already done that a little bit. This will only work every 5, or won't work every 5 minutes, but between those requests, currently it'll continue to work, but we can do a little bit more with it. Before we go any further, we need to talk about some of the implications of offline development. Now, I appreciate that most people in this room are probably PHP or backend related, and maybe you just saw that JavaScript and went, oh my god, and now I'm going to talk about UX and it's going to get worse. But you do need to take into account your UX considerations for this. If you're building a financial application and you're telling your users that they're seeing the current trading price of whatever stocks and actually they're not online and you're just faking it from your cache and you haven't told them that, it's probably not a good thing, and you should probably tell them that. So make sure that you're updating your UI. Now, remember that the service worker doesn't have access to the DOM unless you use the post message API, which is a little bit dodgy at the moment. There are other ways, so we are going to have a look at that, at how you can do that. Just make sure you do it, because I have seen some PWAs out there that aren't doing it, that are just like, oh yeah, we work offline, it's fine, and we just don't need to tell our users, and then I missed my train because they didn't tell me. It's okay, I wasn't late today. So, offline support. This is the same code that we saw earlier. This time we're going to have a look at this bit in purple. How do we get this to work if we're not online? The code gets quite long here, so I'm just going to kind of break it down into simple bits for you. Now, when we do a fetch request from the service worker, if it doesn't work, if it fails for some reason, we can catch it. It's promise-based. And actually, it will return a failure through our promise if you're not connected to the internet. If it doesn't get a response, then it falls into the catch. Now, okay, I'm just assuming here that any failure means you're offline, and that's not true, obviously, because it could be failing for a different reason. But I ran out of room on my slides to write all of the if statements of the different things that it could be. So let's just go with it. So it's fallen into the catch, that means we're offline. So now in here we can go into Indexdb, and we can go and get the data from there. So even if that 5 minutes has elapsed, and we know that we need to go and get some fresh data, but we can't because we're offline, we can then just go into the Indexdb, go and grab it, and send it back, so that at least their browser isn't just sitting there hanging. Now, you can also now do this from your client side. You can do this without your service worker. There are 2 new events in some evergreen browsers called online and offline, which will trigger when your online status changes. Okay, so here I've just written a really quick function that just updates the UI by displaying a div when your online status changes. So you could do this, as I said, from the service worker using the post message API, but the code gets really long, and actually this is much easier. I haven't found any discrepancy between when the service worker thinks you're online and when the front-end client thinks you're online. There might be, but hopefully not. OK, so let's have a look at what's going on again. So now we make our initial request to the API. Sorry, was somebody trying to take a photo of that slide? Do you want me to go back? No? OK, cool. OK, so our user makes the request to the API or to the page, whatever. HTTP request goes out. The API responds. We store our data into Indexdb, and then we display it. The user performs another page action. Maybe they refresh or they go to another page that requires the same data. Service worker kicks in, performs the fetch request, or falls back to Indexdb if the network's down. The client UI receives the response, regardless of where it came from, and updates the DOM. And if we've got that bit of online detection in there, it also updates the DOM to tell them they're offline. Make sense? OK, other cool things that we can do. This code does get really quite long, so I've really shortened it. But we can do this thing called background sync. Now, last time I gave this talk, somebody mentioned the fact that you could kind of do this from just the client UI. And yeah, you can, but I'm talking about service workers, so I'm going to stick with it. So in my client, app.js, I've got a button, which when I click it, it's going to update my trains. Now, instead of actually just making a fetch request, what it's going to do is it's going to register a sync with my service worker. Now, in my service worker, I can pick up that sync, and I'm going to check, is this particular sync that's fired the one for update trains? If it is, then I'm going to execute my update trains function. But I'm going to execute my update trains function inside an event wait until. Okay? And what that will do is it will mean that the service worker, which runs in a separate execution thread to your normal JavaScript, will run that function, wait until the promise comes back, and then send it back to the UI. Now, if you're offline, the promise isn't going to come back from that. It's just going to wait until you are online. And when you're online, it's going to make the request, come back, and then it can update the front end. It means the front end isn't actually waiting. There's no hanging as far as the request is concerned, because the fetch is actually being done by the service worker thread, not by your UI thread. If you did it the other way, and you did it using the isOnline event in the front end, then you would get your browser would hang. So basically what the user will see is they'll make a request, whether that's saving some data or refreshing the page. It will try and execute update trains. Update train says, well, you're not online, so I'm just going to wait until you come back online, and then I'm going to make the request. So if you're saving profile data, for example, now they can click save. The service worker will register, right, I need to do this when they come online, and then they can continue to use the app. As far as they're concerned, it's saved. It's not actually saved on the server, but as soon as their device connects to the internet again, it will make that request and save it in the background quietly without them noticing. OK, yeah, the client UI will come back and they'll get a little pop-up that says it's been saved at that point, or whatever your client UI does. So you probably want to, if they're not online, pop something up and say it's not actually saved, but it will save as soon as you come back online. As I said, remember to update your UI. But that's up to you how you manage that. OK, so I've been talking all about the cool things that we can do with PWAs and all the benefits, and like you're probably thinking, OK, there's got to be a downside. There's a downside to everything we do, right? Compromise. So there are some limitations. So storage limitations is the main one. On iOS, currently, it's a 50 megabyte limit. That's on the device, so and across everything. So that's the size of your JavaScript, HTML, CSS, images, and any data stored in a cache, and any data stored in Indexdb, and basically total. Okay. If you break 50 megabytes, you don't get the. You can't have a PWA. It's too big. If your initial install is less than 50 meg, and then you try and put stuff into Indexdb, and you breach the 50 megabytes, your promise responses will just start to fail. On Android, they change it about every 2 weeks. It was like 2 gigabytes, and then it was 200 meg, and then it was 1 gigabyte, and then it went up to 2, and it's more than you need is the answer. If you're storing 2 gigs of stuff on their phone, then probably stop. And my clicker's not working. Oh, there we go. Okay. So other limitations. iOS auto deletes them, which when I first read, I was like, what? So my application's just going to get deleted randomly? Well, it's not quite random. If they don't use the app for a couple of weeks, then iOS will just delete the background files. It does delete the Indexdb data too, which is great. Basically just clears up the space off their phone, but it keeps the icon on their home screen. So as far as they're concerned, nothing's changed. But the next time they click that icon, it will re-download everything in the background as if it was the first time that they'd done it. So it's not a big limitation. It's just something that you have to be aware of. So for people like Trivago, who you only use the application twice a year, basically every time that somebody's opening it, they're re-downloading the whole thing. The other one is your limited native access. So at the beginning of this talk, I talked about, well, the idea of a PWA is that it looks like a native app, it works like a native app, and the users can't tell the difference, except they don't have to install it through the App Store. Which all sounds great, but actually we don't live in that world yet. A lot of native features don't currently have an API for them. Most of them, or a lot of them, are coming. There was a great talk last month at DPC, Dutch PHP Conference, on web API stuff that's coming. So if you're interested in that stuff, please go watch that talk. It was really good. I can't remember the name of the guy that gave it, but sorry. Anyway, so things like Bluetooth, like your Touch ID, so your fingerprint scanner, like Face ID on your iPhone, and like all the battery information. I mean, that one actually is not. That one works now, but app payments, so like via Google Payments, none of that stuff works with a PWA yet. You don't have access to it through your service worker, and depending on the device that you're using, you don't even have access to it from the client UI. Some of them do. Support is patchy, but it's getting there. But in comparison with what you can do natively, it's definitely not there yet. Hopefully soon. On iOS, you can't do push notifications from your service worker, and there's no Siri integration either. Fortunately, there's obviously no Siri integration on Android. But it does work with the Google Assistant, which is quite cool sometimes. So what does this mean for you? What is this actually going to change? Well, one, probably brush up on your JavaScript if you're only writing PHP. Sorry, I'll leave now. It doesn't mean that you should bin your native application. I've had that question a few times, and no, please don't bin your native application just because I said so. Maybe soon, maybe 12, 24 months, but probably not yet. It depends what your native application does, but based on the limitations of storage space on iOS and the native features that you have access to, you're probably using things that we can't yet do with from a PWA. But that doesn't mean you shouldn't do one anyway. It still gives a better experience to your mobile web users. It just can't replace your native application quite yet, probably. However, what it does mean for you is less HTTP requests. Less traffic to your server because you have more control over the cache, you have more control over your client network traffic, and generally that means good things for your server. Overall, that's probably what it means for most of you. Obviously, it means the same UX concerns that I was talking about earlier. You need to make sure that if you're doing this stuff, that you're telling your users what's happening. Please don't not tell them that they're offline. Okay, some resources. So ServiceWorkRS is run by is a Mozilla site. This kind of will do a lot of your work for you. You basically just, on the left-hand side, it's got a big menu of things that you want to be able to do, like cache management or pushing notifications, or there's a whole long list of different things. Background syncs on there, and if you click on them, it gives you all the information about it, and then it'll give you the code to do it as well. Obviously, you have to update that a little bit to work with your particular application, but most of what you need is actually on there, which is great. The other one, PWA Stats. If you're not already convinced by this, please go here. It's basically just a big list of people that have built PWAs and then what they found off the back of that. Testimonials, if you like, for PWAs. It's where my stats from earlier came from, and it's being updated all the time. It's actually really interesting. I should also mention there is a site called PWA.rocks, which just contains a load of examples of really cool PWAs and loads of things that people have done with them. So if you want to go and check out some of the stuff that people have already done, then PWA.rocks will give you that. And that's it. Any questions? Am I shouting them out, or are you just going to run?
Yeah, we'll do the mics.
Thank you, mate. Sorry, going to work out. Well, you can hear me. So my question is probably, maybe I misunderstood, but how do you use like front-end frameworks like React, Angular, Vue? Would they integrate in with the PWA? Is that installed as part of the package?
So you actually don't need to change any of your, in case anybody didn't hear. The question was, how do you use your front-end frameworks like React and Angular with the stuff that I've been talking about? The answer is that you don't need to change anything that you've already got. You can do everything that I just talked about without actually having to change any of your front-end client code at all. Okay, there's the UX stuff that I talked about, updating that. Yeah, I'm going to say it a billion times. So you do have to change that, of course. But otherwise, you don't actually have to do anything. It doesn't need to affect what you've already got. You can literally just register your service worker, and then it runs in a separate execution thread. You write that in a separate service worker file, and it can handle everything completely separate to the rest of your application. So you actually don't need to like bug any of that stuff or change any of that stuff at all, which is kind of what's really great about it.
Cool. Can I ask two questions?
Yeah.
The other's about signing in. How do you like sign in, verify your users, authenticate? Is that done as part of the PWA?
I mean, that kind of depends on your implementation. So if you've got a REST API, for example, then you're using OAuth probably, or auth headers at least. If it's not using a REST API and it's actually just server-side rendering, then it's being sent as part of the initial request, and you've got some kind of session. None of this should affect that at all. The request that you send from the client to the server, the service worker can see it, and yeah, okay, it could strip out the auth headers if you wanted it to, but if it don't do that, and then it will work. It has access to the request, but unless you specifically tell it to edit that request, it will just send the request as normal, authorize, and continue to work.
Hello? Hello?
Yeah?
Hello?
Yeah, I don't think it's working.
Okay,
Yeah.
Basically, JavaScript over PHP, which one? Because most of your stuff was JavaScript, it was JavaScript.
Okay, so the question was, do I prefer JavaScript or PHP?
I have another question after that.
Okay, I don't know. That's a tough question. Probably
PHP.
No.
Say it.
No, I do really like PHP. Actually, it's definitely better from the fact that it's more predictable. JavaScript just does some weird things. That being said, I've got another talk called "What the Fuck PHP." So, but I do like the flexibility of JavaScript. So, you know, the right tool for the job.
And one of the other things.
Okay.
So, for example, legends there about caching your login information.
Oh, okay, caching your login information. Okay, yeah.
With PWA, is that possible? So next time they don't have to actually log in, they've actually got that cache stuff.
Oh, I see.
Geolocation, all stuff that you do on JSON.
Yeah, I mean, you could store the fact that they were logged in into the cache or into Indexdb, I suppose, so that the next time when they hit the page, the service worker can just check, are they already logged in, and then take them there. Yes, there's no reason you couldn't do that. It's not something I've done or thought about, I have to be honest, but there's no reason you couldn't do it. Yeah. I mean, it's just client-side storage, so at the moment, if you're using sessions or whatever to store the fact that they're authenticated, then you're using a cookie anyway, which is the same principle here. You're just not using a cookie, you're using a cache or Indexdb, so there's no reason why not. Yeah.
I was wondering if there's likely to be any support for this in desktop operating systems.
So service workers are supported in your pretty much across all of the evergreen browsers. Edge. Nah. I'm going to leave it there. But as far as actually like converting it into what appears to be a native application, there's Google have been looking at doing it for things like the Chromebook, because it's basically just a mobile, it's basically just Android anyway. But as for running it actually on like iOS or Windows, currently, I mean, Windows are really, Microsoft are interested in doing it for Windows 10, because they kind of are claiming that it was their idea, but whatever. But iOS, OS X for Apple, not that I know of. They're actually, in this one, a little bit behind the curve. They were the last ones to implement service workers into Safari. That only came out about 4 or 5 months ago now. So the likelihood of them putting it into OS X, I think, is probably not for a long time, if it ever happens at all.
Second of all, how do you do testing of these PWAs? So, for example, how would I go about testing what the behavior is when I breach this, storage limit? How would I test this? I'm kind of familiar with Jest and how you test things in Jest for React components. How does that work when you're trying to test how your PWA behaves when you do something really bad, like exceed the storage limit?
Okay, so the question was, how do you test this stuff? I have no idea. Acceptance tests, like browser tests, maybe. I've never done it. Yeah, that's my answer. Sorry. I don't know. I mean, I suppose if you put, you can put most of your stuff, you can put most of the functionality into just functions, which then can be testable, of course. The only bit that I wouldn't know how to test would be actually the event detection. So I guess you'd... No, I'm done.
Okay, I think we've got time for one more question. No? No? Yeah? Okay.
Do PWA have access to microphone by any chance?
Does it have access to the microphone?
Yeah.
So it depends on your device. Sorry?
So it has background sync functionality, right?
It does, yes.
So if it has access to microphone, could you technically write those background service worker as using the microphone to red code stuff? I haven't seen it.
So all of the, I say all, yeah, no, all of them actually as far, well, okay. A lot of the web APIs for using particularly native hardware, but native type stuff, have request bubbles on them. So the user has to say, yes, I give you authorization to use this. But yes, in theory, if your users said, yes, they can record, then yes, you could record stuff. The limitation would be that the web APIs don't, because they run on the client, not on the, you'd start it on the client and then use the service worker. So the client doesn't run when the application isn't up. So if they were on your application, yes, you could be recording them in the background, but that wouldn't change. That's not something new that a PWA could do. You can already do that. Don't. So there's not a big difference there, really. The client itself, because the client is the thing that would be talking to the microphone, doesn't run in the background.
Real background things only when you're using the PWA app.
Yeah, you still have to be using it. Yeah. Yes. Okay.
Okay, I think that's it. So thank you, Mike.
Okay. I do have one more slide just to say I welcome feedback on this. I don't think we're joined in, but please come and say hi to me afterwards or tweet me or whatever, because I'd love to know your thoughts. Okay, thank you.
Thank you very much. Sorry, I need the...
Oh, do you want me to? Sorry. Yeah.
Okay, just bear with me. We have not finished yet. Still got a couple of minutes. Just, fingers crossed this time with the slides. Okay, where's that thing gone? Oh, is it? This one. Yeah. Okay, anything? No? Something? Nothing? What's going on? Ooh. Okay, so for those of you who have we got something, there we go. Okay. Cool. So for those of you who have been here before, or not, we have a raffle. So we have 2 free licenses for any JetBrains products. So PHP Storm, IntelliJ, Python, the Ruby one. It's the same joke every month, but it's the Ruby one. PyRuby, whatever it is, Ruby, whatever, Ruby Storm, Ruby J, I have no idea. So if you see a name, just stay where you see it for the time being, and come and see me after, and I'll send you a license. So, Jason Ossay? Anyone called Jason? No? Jeremy Lawrence? Anyone called Jeremy or Lawrence? It's still a void has been here all day. Cornell Andreeve. Anyone called Cornell? Carlos Jimenez? Okay, just wait there for a second, but yay. Phil. There must be Phil, Philip, Phyllis, Felipe, Kyle. Anyone called? God, no. Okay. Stefan. Anyone called Stephen? Okay. So, yeah, just come and see me in a few minutes. So, congratulations. I do have one more slide somewhere. Where's my map? Okay. Okay, can anyone see that? Okay, no. pub. Yay! All that work for the pub. So, yeah, for those who haven't been before, we meet up at the Sir Christopher Hatton, which is just through the revolving doors, slightly to the left, and then over the road. That's pretty much it, really. I've got one more announcement, I guess. This month is my 3rd year anniversary organising, so I'd like to thank everyone who's ever spoken, who's ever attended, who's ever just helped with the user group in general. So thanks to Sam and everyone else. So yeah, I'd like to thank our sponsors again, so Cloudflare, Nexmo, Lendinvest, and Explore Group. And yeah, lightning talks, if you're interested, please come and see me with a capital P, please. I think we've got 3 so far. Ideally we want like 5 or even 6. So if you've got an idea, come and see me. And thank you very much, and I'll see you next month. One last thing, if you brought any drinks in, can you please take the bottles or cans, please, and put them in the bin? Thank you. And thanks to Mike for coming all the way. Thank you very much.